Hello there, pre-calculus students. This is Mr. Kashi speaking. In this video, we will be going over our second concept of our 9-1 lesson in basic combinatorics. We just went over the multiplication principle and factorials. Now we're going to go over something called permutation or permutations. It's always important to remember when we're talking about permutations is that order matters. When we choose something first and then choose something second, that is going to be different than the other way around, which is going to be opposite of when we were talking about combinations. So in this case, we have three different words here. They're 9-letter words, and we want to know how many different ways we can write them. And so for A here, we have the word dragonfly, and it's important to know that we are looking for the amount of different letters. Okay, so dragonfly, there are no repeats. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. Okay, so we have no repeats. That would be 9 different things to choose from. So that's 9 factorial, and that would be 362,880, which seems like a lot for a 9-letter word. Then moving on to B here, butterfly. The word butterfly only has one repeat, which is T, and so then we're down to 8 letters, and we go 8 factorial there, which is down to 40,320, which seems like you only repeat one letter and you go from 362,000 down to 40,000. That's a pretty big leap. And then for bumblebee, now we have a lot of repeats. So if you start with the first B, we can cross out the other B's here. And then we have E, and then those E's there. So we really have 1, 2, 3, 4, 5. We have 5 factorial, 420. So it's just a quick way to kind of get back into thinking of counting different scenarios. So this is a permutation example. We have 4 colors here, and let's say that we are asked to find how many arrangements can happen from choosing 2. Choosing 2 colors. Now remember, order matters with permutations. Okay, permutations, order matters. So we want to know if they're in different orders. So here, if we choose 2, we would have green and blue, and then we could have green and red, and green and purple. Okay, hopefully you can kind of see where this is going. So we then let's do all the ones that start with blue. So we have blue and green, blue and red, blue and purple. You can do all the ones that start with red. We have red and green. We have red and blue, and we have red and purple. And then we can do all the ones that start with purple. So we have purple and green, we have purple and blue, and we have purple and red. Okay, so we have all these different arrangements, and you can see we have 3 rows of 4 different arrangements. So this would be a total of 12 arrangements. Now, once again, that's going to be quite a bit if we start having numbers a lot higher than 4. So we're gonna go on and see if we can come up with some sort of formula to make this process shorter. Okay, so I want to move on to one more example here that hopefully will help out. And we have what I call the Snow White example, or the Snow White problem. If we were in class, we'd be taking volunteers and find out who's Doc and Happy and Dopey, but here we're not going to be able to have that fun. But we're going to say we have 16 actors answering a casting call to try out for roles as dwarfs in a production of Snow White and the Seven Dwarfs. So obviously there are 7 dwarfs, of those roles that need to be filled, and we have 16 people to choose from. And how many different ways can the director cast the 7 roles? Well, if we were to do this in order, and we have categories here, obviously we have roles, we can't be switching those. Order matters. So if we wanted to cast Doc first, we'd have 16 options there. And then if we were to move on to Happy, then we'd only have 15, and then so on and so forth down the line. But we'd stop at 10. That would mean that obviously 9 people wouldn't be able to be casted as the 7 dwarfs. And so you can multiply those out. And once you multiply those out, you get the very large number of 57,657,600. Now that's if you're talking about 16 people and 7 roles, there's 57,657,600 ways to arrange them, which seems like an astronomical amount, seeing as you're just talking about 16 people. But once again, this is getting to be, even if you didn't want to multiply the 16 times 15 times 14 times 13 times 11 times 12 all the way down, there's got to be a faster way of doing it. So there is a formula that we use for permutations, and they deal with factorials. And so here we have n factorial on top, and then we have n minus r factorial on the bottom. And so P just stands for permutation. N is going to stand for the total number of options in any given situation or arrangements, and R is the number of favorable options. So when we say favorable, let's go back. We're going to use this here for our 2 examples that we just did. Okay, so here we would have, remember, so we have NPR equals n factorial over n minus r factorial. Okay, so in this case we would have 4p2. We are choosing 2 of the 4. And order matters, so that's why we're using permutations. So we would have 4 factorial over 4 minus 2 factorial. So 4 minus 2 factorial would be 2 factorial. And if we were to write that out, we'd go 4 times 3 times 2 times 1 divided by 2 times 1. So hopefully you can see that when this happens, we can cancel the 2's and the 1's out, and we get 4 times 3 equals, well, we get 12, sure enough. Okay, so that's how kind of the longhand way of doing it. Really you could just do this 4 factorial divided by the 2 factorial in your calculator, and you'd be able to figure that out. So let's do that for this problem here. So we would have 16 choose 10. So this would be 16 factorial over 16 minus, we're choosing 7. There's 7. Let me start that over real quick. We have 16 permutations, 7. Okay, and so that would be 16 factorial over 16 minus 7 factorial. There we go. And so then we have 16 factorial divided by, 16 minus 7 is 9 factorial. And as you can see here over at the end, we don't have anything past 10. The 9 times 8 times 7 times 6, that all got divided off. And so this 16 factorial divided by 9 factorial, if you were to plug that into your calculator, you'd be getting the same thing. So this is a rather important formula when you're talking about when things have order that matters. So n factorial divided by n minus r factorial is your permutation formula that you want to be using for those types of problems.